Okay, well, since I am not at school today, I thought I would go ahead and work out on paper, work out the answers to worksheet 5, the continuity worksheet. All right, so this is how I would do these problems. All right, for what values of x does f have a discontinuity? Discontinuity is any value of x that makes a denominator 0. So I would say add x is equal to 2 and -2. I answered the question. That's all I need to say. Okay? For what values of x does f have a discontinuity if f is this? The numerator does not matter. X is equal to 5 and -3. Does not matter what's on top. Which of the following is continuous at x is equal to 2? Continuous at x is equal to 2. So I know that this one, the way it's set up, I know that there is a hole or a vertical asymptote here. So let's find out what's going on. Okay, if x is not 2, then we're at this. So does the top factor? The top does factor into x minus 2, x minus 1. Okay, so I do have a hole. I put 2 into the remaining x and I get 1. So as 2 goes into that, there's a hole right at the point 2, 1. The hole is at the point 2, 1. When x is 2, I'm up here at 2. So there's a hole, and it's not filled by the bottom one. So not continuous. Which of the following is continuous? So that one is not continuous. Over here, the only discontinuity is that x is equal to -2, but right at 2, yes, we are continuous. So G is continuous. For H over here, okay, I'm going to plug 2 in for x. So I get half of 2 is 1, plus 1 is 2. Put 2 in for this x. 4 minus 2 is 2. They match. And then right at 2, we're up here where it's 2. So 2 is equal to 2 is equal to 2, continuous. So 2 and 3 are both continuous. C is the right answer there. What value of k makes f continuous? I'm going to put a half in for this x, a half in for that x, a half in for this x, set them equal to each other. So I'm going to have k over 8 minus k over 2 minus 1/4, setting that equal to 16 over 4 minus 2. This is 4 minus 2, which is 2. I'm going to multiply both sides by 8. I get k minus 4k minus 2 is 16. So -3k is 18. Goodness gracious, do I not have the right answer on this one either? You've got to be kidding me. K is equal to negatives. Oh, I do have it there. Okay, perfect. Perfect. Okay. Alrighty. Let's go on to the next page. Alright. G is a piecewise function shown on the right. Which of the following statements is true? We want it to be true. Be careful with that because every once in a while they'll say which one is false. Okay. Infinite discontinuity. Removable discontinuity. Removable discontinuity. So infinite discontinuity means it has to be a vertical asymptote. So is there a vertical asymptote at -2? Yes, there is. So that is true. Removable discontinuity. The only removable discontinuity is a hole. Is there a hole at -1? At -1, there's a jump discontinuity, not a point discontinuity, not a hole. So this is not true. There's no hole here. It's a jump. Removable at x equals 2. At x equals 2, yes, there's a hole right there. So yes, removable on that one, not removable on this one. So 1 and 3 only, B. Which of the following functions has a jump discontinuity? Add pause really quickly. Okay, which of the following has a jump discontinuity at x equals 2? Jump discontinuity at x equals 2. The first thing I'm looking at here are these values, the way they express these. These are all inequalities. There's no like not equal to. So each of these has the potential to be a jump discontinuity. All right, I'm going to put 2 in for this x, and I get 3 times 4 is 12, minus 8, plus 1. 4 plus 1 is 5, so that piece is 5. Put 2 in for this piece, and that's a 6. There's a jump there, so yes, that one has a jump. Put 2 in for this x. 2 times 4 is 8, minus 6 is a 2. Put 2 in for this piece, we get a 4. 2 is not 4, so another jump there. Okay, 2 in for this piece. 3 times 4 is 12, minus 10, plus 2, that is 4. Put 2 in for this piece, and we get 4. Those match, so there is not a jump there, not H. So only F and G. A. Okay, determine if F is continuous. Now, this is an FRQ, so to determine if F is continuous, we must show the limit from the left, the limit from the right, and F at 3. Okay, so let's do that. So the limit from the left of 3 of f of x is equal to, okay, so from the left I'm going up and using this piece because that's where x is to the left of 3. Okay, I'm going to simplify this thing, and that is x plus 3, x minus 3 over x minus 2. Okay, since x is not 3, since x can never be 3, we can reduce those. That is the only reason we can reduce those, though. So this is the same as just x plus 3. And if I put as x goes to 3 from the left, that is going to be 6. As x goes to 3 from the right of f of x, now we're using this piece because it's on the right of 3. That's going to be 9 minus 3, which is 6. And now I must say what f at 3 is. What is f at 3? Well, f at 3, we use this piece because it's the first time that we've used that equal to. We're putting 3 in for that, and of course that's going to be 6. So then I can say f is continuous at x equals 3 since the limit from the left of 3 of f is equal to the limit from the right of 3 of f, and that is equal to f of 3. So this is what is required to get credit for this. Okay. Determine if G is continuous at x equals 5. All right. So once again, the limit as x approaches 5 from the left of G, the limit as x approaches 5 on the right of G. Okay, and then we'll need to find G at 5. Okay, so once again, I can factor the top, x plus 5, x minus 5, divided by x minus 5. X is not 5, therefore we can reduce those. The only reason we can reduce those is because x cannot be 5. So this is the same thing as x plus 5. And if I put 5 in for that x, I get 10. The limit on the right, I'm still using this. I'm still using this because this is whenever x is not 5. So this is still 10. Okay, what is G at 5? This is the only time I'm using that. G of 5 is 0. G is not continuous at x equals 5, since the limit as x approaches 5, and you can, if you want to, you can say left, right, whatever, but the limit as x approaches 5 of g of x is not equal to g of 5. In this case, both sides are the same, so it doesn't matter which one. But even as long as one of those didn't match, we would be done. Alrighty, number 9. The graphs of f and g are shown on the interval -3 to 5. The graphs consist of line segments except where f is equal to this nice weird function on the interval from 0 to 2. So they give us the equation for that. Alrighty. Let h be g of f of x. Find the limit as x approaches 4 of h of x. So, use correct notation in your answer. Of course, they don't have to tell us that because we're going to do that anyway, right? Okay. Limit as x approaches 4 of h of x. Okay, so first I go to the inner function. I find the limit as x approaches 4 of f of x. What is the limit as x approaches 4 on f of x? Well, the limit is 2. And I notice that it's coming from below. Both sides are coming from below. Now, I find the limit as x approaches 2 from the left of the outer function g. Okay, so 2 from the left is 1. Therefore, the limit as x approaches 4 of h of x is 1. That's what I'm expecting from you guys, okay? Let k equal f of x plus g of x. Consider x is equal to 1, 2, and 4. At which one of these values does k have a jump discontinuity? A jump. Justify your answer for the jump discontinuity using correct limit notation. Okay, so I'm first going to consider x is equal to -1. Alright, so I'm going to do this for myself first. What is f of -1? What's the limit f of -1? F of -1, that is as x approaches I see a discontinuity. Hang on, the bunny is right on my feet. Hang on just a second. Okay, sorry about that. Alright, so let's say, okay, first I'm going to do -1. Limit as x approaches -1 of k of x. And k is f of x plus g of x. So let's first come from the left, and then we'll go from the right, go from there. Okay, from the left. So from the left, for f of x, we're at 0. G of x, we're at -1. So this is -1. Okay? So now let's do the limit as x approaches -1 from the right of k of x, which is f of x plus g of x. So from the right, I get 1 for f of x. From the right, I get 1 for g of x. So that is 2. So the limit from the left is -1. The limit from the right is 2. That's a jump. That's the definition of a jump, right? So I can say k has a jump discontinuity at x equals -1, since the limit as x approaches -1 from the left of k of x is not equal to the limit as x approaches -1 from the right of k of x. Okay, that's how we do these. So next up, we're going to consider 2. Same thing. Limit as x approaches 2 from the left of k of x. So 2 from the left. 2 from the left is 0. And on G, 2 from the left is 1. Okay, limit as x approaches 2 from the right. 2 from the right. 2 from the right would be a -2 for the x. 2 from the right would be a 3 from the for G. So this ends up to be a 1. These two limits are equal. If the two limits are equal, K does not have a jump discontinuity there. So K does not have a jump discontinuity at x equals 2, since the limit as x approaches 2 from the left of k of x is equal to the limit as x approaches 2 from the right of k of x. Alrighty. One more. Get a different color here. Alrighty. One more for x is equal to 4. Same thing. So limit as x approaches 4 from the left. So 4 from the left. 4 from the left is 2. For f, 4 from the left is -3. So that'll be a -1. 4 from the right. Four from the right is 2 minus -3, which is still -1. So just like what happened at 2, the two limits are equal. So K does not have a jump discontinuity at x is equal to 4, since the limit as x approaches 4 from the left of k of x is equal to the limit as x approaches 4 from the right of k of x. Part C. Values of f at selected values of x are given in the table. What type of discontinuity does f have at x equals 1? So at x equals 1, we have a hole, right? We have a hole, which means that we have a removable. So f has a removable or point discontinuity at x is equal to 1. Based on the values on the table, what is a reasonable estimate for the limit as x approaches 1 of f of x? A reasonable estimate. So once again, okay, somewhere between, looks like it's a little above 2.5. I could, if I wanted to, put 1 in for the x here and find the exact value, right? That makes me question that function. I wonder if that function, anyway, I'm going to go on. So right here, surrounding it at very, very close points, surrounding x is equal to 1, we have these y values. So I would pick the y value that is in between those. What y value is in between those? I would say that it's a reasonable estimate would be halfway in between those. So 2.618 would be halfway in between those. Alrighty. And then lastly, write a difference quotient that best approximates the instant rate of change instant rate of change of g at x equals 4.5. So I go to 4.5. Here's 4.5. It would be right there. It's asking what is the slope between those 2 points right there. So to show my work, I'm going to say change in g over change in x, g at 5 minus g at 4 over 5 minus 4. So that would be a difference quotient. Okay, g of 5 is -1, g of 4 is -3 over 5 minus 4 here. So that is -1 plus 3 is 2. So that instantaneous rate of change is 2. And we did 10 in the notes. So if you need that one again, you can go back and look at the notes for that.